Welcome back. Today we're going to cover another theorem that you can use to solve some geometry problems on the AMC and other contests. It's called Menelaus Theorem, and it is really similar to Cheva's theorem in its statement. If you want to read it, pause the video here. Okay, now we're going to prove this theorem. Alright, so first let's draw the heights from each of the three vertices to the line DFE, and for notation, let's call them h sub a, h sub b, and h sub c respectively. Now first, we notice that the triangle here is similar to this triangle here. And thus we can write that the ratio BE over EA is equal to the ratio of the heights of the triangles, which should be h sub b over h sub a. And similarly, we can write, since this triangle here is similar to this triangle here, that AF over FC is equal to h sub a over h sub c. And finally, since this triangle here is similar to this triangle here, we can write that CD over BD is equal to h sub c over h sub b. And therefore we have, when we look at all of these again, that AE over EB times BD over DC times CF over FA is equal to HA over HB times HB over HC times HC over HA. And this down here is obviously equal to 1. And therefore we have proven the Menelaus theorem. Now the Menelaus theorem is very similar to Cheva's theorem in that it is also an if and only if theorem. I've only proven the if part, namely that if we're given that D, E, and F lie on the same line, then we know that this equation is true. But the reverse is also true, which is to say that it's also an only if statement. I'm not going to prove this reverse theorem here. It follows a very similar process to how we prove the reverse of Cheva's theorem. And in my video proving Cheva's theorem, I have proven the reverse. So I highly suggest that you check that out. The link will be in the description. Alright, so here's a really quick and easy example. Real contest problems aren't going to be as straightforward as this one. But this is here just so that you can get used to what this theorem is saying, and so also so that I can introduce an easy way to memorize Menelaus theorem. And so we can start at vertex A here, and we're going to look in turn at each of these line segments in this order. So what do I mean by that? First on our list is AE, which is 5. The next one is EB, which is 3. And the next one is BD. So be careful here, we need to add 7 and 15 together. So that'll be 22. And then it will be DC, so 15. And then CF is what we want to find. And finally we have FA, which is 6. So by looking at these 6 line segments in this order, we can very easily find the Menelaus theorem in this case. And we can solve for CF. And we would find that in this case, CF is equal to 27 over 11. So this is the Menelaus theorem. It's also called the Menelaus theorem. I probably said it both ways in this video. So thank you very much for watching, and tune in next time.